Hi, welcome to my proofs with isosceles triangles. Proofs with isosceles triangles. Definition of an isosceles triangle is a triangle with at least two sides equal. It has at least two sides, so that means you could say that an equilateral triangle is isosceles because it has two sides equal. But we look at the parts of an isosceles triangle with exactly two sides equal. Here's the triangle ABC, in which the sides AB are marked with one stroke, so that means AB is equal to AC. The two sides are equal. AB is equal to AC. The vertex angle or apex angle formed by the equal sides. So the vertex angle is the angle formed by the two equal sides, and that's the vertex angle or apex angle is angle A. The base is the side not equal. So the base is BC. That's the side that's not equal. That's the base of the isosceles triangle. The base angles formed by the base and the equal sides. So the base angles are angle B and C. B and C are the base angles. This is the apex angles formed by the two equal sides. Or it could be said the angles opposite the equal sides. So the base angles are the angles opposite the equal sides, B and C. So let's look at an isosceles triangles and pick out the two equal sides, the vertex or the apex angle, the base, and the base angles. So in this triangle, the two equal sides are PQ equals PR. The vertex angle or apex angle is angle P. That's the angle formed by the equal sides. The base is QR, because that's not the equal sides. And the base angles are Q and R. Angle Q and angle R. In this triangle, the two equal sides are TV and TX. They're equal. The vertex angle or apex angle is angle T. It's the angle formed by the two equal sides. The base is XV. And the base angles are X and V. And a bit of practice means you can pause the video and work these out. Practice. These sides are marked with 4 strokes each, so the equal sides are H, E, and HF. The vertex or apex angle is angle H. That's the angle formed by the two equal sides. The base is EF. And the base angles are angle E and angle F, base angles. Notice the base angles E and F, and EF is the base. D, the two equal sides are marked with 1 stroke each, so that's a KI and a KJ. The apex angle or vertex angle is K, angle K. The base is IJ. And the base angles are angle I and angle J. Okay, let's continue. Okay. We have a triangle RPQ, and we're given that PQ equals RQ. And their sides are marked. So I have a statement that PQ equals RQ as the given. So the triangle PQR is isosceles, definition of an isosceles triangle. So anytime you want to prove that a triangle is isosceles, we had to prove that the two sides are equal. So we got two sides equal, so we have an isosceles triangle. Now we have a theorem that I call the isosceles triangle theorem. ITT, isosceles, I, triangle T, theorem T. The isosceles triangle theorem says if two sides of a triangle are equal, then the angles opposite the equal sides, or which are the base angles, are equal. So if two sides are equal in a triangle, then the base angles are equal. The angle opposite the equal sides are equal. Let's look at that in terms of looking at a diagram. EHT, notice that given that EH is equal to ET, because we have it marked, that's the given. EH is equal to ET. And we have angle H equals angle T, and that's called the ITT. Instead of writing this statement out, if two sides of a triangle are equal, then the angles opposite those sides are equal. Just write down ITT. Base angles are equal. And here we have a triangle. We're given that GH is equal to GI because they're marked with double strokes. And we got to prove that H is equal to I, which are the base angles. So GH is equal to GI given, and angle H is equal to angle ITT, because these are the two angles that are the base angles opposite the equal sides. And practice means pause the video and work these out. Here we go, pause the video. If you wish, we're given that XA equals XB, two strokes. So XA equals XB given. And that means that angle A is equal to angle B, ITT. So two sides are equal in a triangle, then the angles opposite those two sides are equal. Notice you got two equal sides, two equal angles. If you had three equal sides, you would have three equal angles. If you have no equal sides, you have no equal angles. Number 2, we're given that EV equals EM. EV is equal to EM. So EV is equal to EM given. Now remember, I can put 1s in these and 2s to indicate the steps. So like that's 1, goes to 1, 2, angle V equals angle M, and the reason is ITT, Isosceles Triangle Theorem, which means if two sides of a triangle are equal, then the angles opposite those two sides are equal, or the base angles are equal. Let's continue. Okay, lower that down there so you can see it. Let's do some examples of some proofs with the isosceles triangle theorem. We have a triangle, as you can see, and we're given that PT is equal to PV. So that's the given. And we have to prove that angle 2 is equal to angle 4. So PT is equal to PV. That will make these two angles equal by ITT. And notice the two lines are intersecting, so 1 equals 2. And these two lines are intersecting, or segments are intersecting, 3 is equal to 4. As a result, if 1 equals 3, and 2 equals 1, and 3 equals 4, then it follows that 2 is equal to 4. So I have put the proof together. So we have angle 1 equals angle 3, ITT. And number 3 step is that angle 1 is equal to angle 2, and we also have angle 3 equals angle 4, and that's because VOAT, or VAT, again, vertically opposite VOAT, vertically opposite angle theorem, or vertical angle theorem, whichever way you want to name it. And as a result, if 1 equals 3, which is right here, and we got 1 equals 2 and 3 equals 4, then it follows that angle 2 is equal to angle 4. Again, transitive property of equality. And again, that's the transitive property. A couple of times, you can say 2 times, but notice if 1 equals 3 and 1 equals 2, that means that 3 equals 2. And if 3 equals 2 and 3 equals 4, that means that 3 is equal to 4. Sorry, 2 is equal to 4. So transitive property twice, but we just say transitive property, check with your teacher. B, we have a diagram here with these angles in it, and we have XY is parallel to WF. So if XY is parallel to WF, mark them like that. And as a result of these parallel lines, we should have angles equal. Let's see, that means that 2 and 1 are equal. Okay, we have XY is equal to XW, mark them with a stroke. That means that these two sides are equal. The angle is opposite, so 1 is equal to 3 by ITT. So if 1 equals 2 and 1 equals 3, it follows that excuse me, 3 is equal to 2. And as a result, we have a bisector. Let's look at it this way. If we look at what we got to prove, YW bisects angle XWF. If YW bisects XWF, if that bisects, that means we have to have 2 is equal to 3. So we have to get 2 equals 3. So the parallel lines will give me 1 and 2. The equal sides will give me 1 and 3. And transitive property says 3 is equal to 2. Because they're equal, we have a bisect. So we have the proof put together. So here we go. XY parallel to WF. Again, it's nice to look at your givens. It's nice to look at what you're going to prove. Put the proof together and everything should come out. So just don't start it. That's what I do. I try to put it together first and then write it down after. So I have angle 1 is equal to angle 2. And that's PLT, parallel line theorem. And their alternate interior angles forms Z. So that's alternate interior angles equal. And number 3, we have XY equals XW. That's a given. Number 4, if we have XY equals XW, that means that angle 1 equals angle 3. That's an isosceles triangle here. These two sides are equal. There they are, marked equal. And so that means 1 is equal to 3. That's the ITT, isosceles triangle theorem. Now we have 1 equals 2, 1 equals 3. So that means angle 2 is equal to angle 3. And that's the transitive property of equality. Transitive property. And as a result of angle 2 is equal to angle 3, that means that YW bisects angle XWF. And because the two angles are equal, that means this is a bisector dividing into two equal parts. Definition of angle bisector. Okay, here we go. Another proof to do. Okay. So we have a diagram, as you can see, with numbers in it. So let's look at the givens. AP equals AQ. AP equals AQ. Mark them with a stroke. So I can see these two sides equal. That means I have angle 3 is equal to angle 5. I got AB parallel to PQ. Parallel lines will give me angles equal most times, so I can see that 2 is equal to 3. So right now I have 5 equals 3, 2 equals 3. That means that 2 is equal to 5. I got QA. QA is this one, is equal to QB, which is this one. So these two angles are equal. I got these base angles equal by ITT. So you can see I want 1 equal to 5. So put all that together by transitive and I'll come up with 1 and 5. So here we go. AP is equal to AQ, given. And as a result of that given, these two sides equal, angle 5 is equal to angle 3. ITT. And AB is a given. AB is parallel to PQ. Notice I'm putting down my givens separate so you can see the organization of the proof. If AB is parallel to PQ, that means that angle 2 is equal to angle 3. They're alternate interior angles forming the Z. So that's a PLT, alternate interior angles equal. And number 5, now notice I have 5 equals 3, 2 equals 3. That means I now have 5 equals 2 by transitive. So QA equals QB given. So if these two sides are equal, QA and QB, that means that angle 2 is equal to angle 1 by ITT. If two sides of a triangle are equal, then the base angles are equal. The angles opposite those sides are equal. So put them all together. 5 equals 3, 2 equals 3, 2 equals 1. So we have that angle 1 is equal to angle 5. And again, transitive property of equality. And again, we can put a 2 in because it's transitive property is not just done once. If we do 5 equals 3 and 2 equals 3, that means 5 equals 2. That's once. So if we got 2 is equal to 5 and 2 is equal to 1, that means 1 is equal to 5. So the transitive property is done twice. Check with your teacher. If that's okay, you got to write each one out separately. And we have a few more proofs to do. Here we go. Practice. Practice means pause the video and work these out. So we have a triangle and the given. We have AB is equal to AH. So let's mark that. As a result of that given, I have these two angles equal by ITT. And because, notice that these are supplementary and supplementary, that means that 1 is going to equal 4. Oh, okay. Here we go. AB is equal to AH. Given. Number 2, angle 2 is equal to angle 3. By ITT. If two sides are equal, then the angles opposite those sides are equal. And number 3, now we got to get into getting, we have 2 equals 3, now I got to go, so I can say that angle 1, angle 2 are a linear pair, angle 3 and angle 4 are a linear pair, and that's definition of a linear pair. As a result, I have angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. That's because of a straight angle. Straight angle. There's a straight angle here and here. And we have supplementary angles, 1 and 2. Supplementary angles 3 and 4. But 2 is equal to 3. So as a result, we could say angle 1 is equal to angle 4 by SAT, supplement angle theorem. So I have 2 pairs of supplementary angles. So these are equal. 2 is equal to 3. That means 1 is equal to 4. We did that proof earlier on with complementary and supplementary angles. And again, learning it early, we will keep using it and using it and using it in proofs. Number 2, we have this diagram. We have AB is equal to AT. BT is parallel to WF, and VW is parallel to AF. Prove that angle V is equal to angle 4. So let's see if we can put the proof together before we start to write it up. If AB is equal to AT, so we have this side equals this side, so that makes 1 equals 3. Okay, we got BT. BT is this side line parallel to WF. So because these two are parallel, that means I get 1 equals 4 corresponding angles. Okay, why did it give me VW is parallel to AF? Notice I did this one with 1 arrow, I did this one with 2 arrows. So if these are parallel, what do we have? Well, we got to get 3 involved. So 3, and we got to get 4 and V, so V got to come into play. So that means if these lines are parallel, and this is the transversal, that means 3 is equal to V by alternate interior. So now we have 1 equals 3, 1 equals 4, 3 equals V, and it ends up that we got V and 4 being equal by transitive. So here we go. I put the proof together, so AB is equal to AT given. Number 2, that means we have angle 1 equals angle 3 by ITT. Now we got BT is parallel to WF as a given. So again, if BT is parallel to WF, that means 1 is equal to 4. Angle 1, their corresponding angles. So PLT, corresponding angles equal. And number 5, so we got 1 equals 3, 1 equals 4. So that means that 3 is equal to 4. Now we have to connect up the V and the 4. So that means VW parallel to AF. Remember, most givens will do something for you in your proof to help you move further. The givens are there to help you do your proof. If not, we wouldn't be able to do the proof. And if VW is parallel to AF, that means that angle V is equal to angle 3. And there's your parallel line right here. There's your transversal. So 3 is equal to, V is equal to 3. And that's a PLT. And it's alternate interior angles equal. And number 7, now we have 1 equals 3, 1 equals 4. That means 3 is equal to 4. So if 3 is equal to 4 and V is equal to 3, that means that angle V is equal to angle 4. Again, the transitive property of equality, and we're doing it at least twice with the transitive property. Okay, all proofs are done very, very similar. Just got to put the information together. And the last one to do, we have a triangle with angles 2 and 3 in it. So we're given that TH, 1 stroke, equals TF. So if these two sides are equal, that means the angle H is equal to the angle 2. So we want, if we look at the proof now, we want angle H, which is this one, equals angle A, which is this one. So we have to somehow get angles equal that involves H and A. So we want H and A, so because these two sides are equal here, that means H is equal to 2. BF, which is this one, BF right here, is equal to BA, which is this one. Because these two are equal, that means 3 is equal to A. So now we have them all put together. We got 2 is equal to H, we got 3 is equal to A, but 2 is equal to 3 by vertically opposite angle theorem. They're vertically opposite angles when two lines intersect. So that's putting them all together by transitive, and we come up with H equals A. So here we go. So I put the proof together first, and now I'll write it out. As the given, as a result of that given, that angle H is equal to angle 2. And that's ITT, Isosceles Triangle Theorem. Two sides equal, angles opposite those sides, H and 2 are equal. Number 3, we got BF is equal to BA, given. And we have angle 3 equals angle A. And again, Isosceles Triangle Theorem. These two sides are equal, so angle 3 is equal to angle A. The base angles are equal, as angles opposite equal sides are equal. Now we have to connect them up, so we got H equals 2, and we got 3 is equal to A. So how are we going to get H is equal to A? Well, get H equals A, we must have 2 is equal to 3. So we look in our diagram, we see angle 2 is equal to angle 3, and the reason is vertically opposite angle theorem, or we can call it VAT, your choice. And now, because we have H is equal to 2, 3 is equal to A, and 2 is equal to 3, that means we got angle H is equal to angle A, and again, transitive property. And transitive property, and we're doing it twice. Again, if H is equal to 2 and 2 is equal to 3, that means H is equal to 3 coming out of these two. So if H is equal to 3 and H is equal to A, then H is equal to 3, that means H is equal to, we have it, yep. So from these two, we have nothing, but from these two right here, we got angle H is equal to angle 2 is here, so angle H is equal to angle 3. And because of this, we have angle 3 equals angle A. And so you can see from 2 and 5, we get these two angles, H and 3. From number 4, we get, this is 3 is equal to A. Because 3 is repeated, H is equal to A. So there's your transitive twice. Putting it together just to make sure. And that ends the proof on isosceles triangles. And if you like my video, click on the like button, the subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.